Okay, so just as we move on, as you might expect, we're now going to be looking for critical regions within hypothesis testing. So the setup's going to be almost exactly the same, and we just know that we find a critical region rather than just testing a particular outcome. So Aisha wishes to test if a five-sided spinner numbered from 1 to 5 is fair. We're going to keep on spinning until we first show the number 1. So geometric distribution, where the probability is 1/5, I would expect 5 spins. I would expect 5 spins before I saw the number 1. Okay, quick diagram. What are we testing for? Let's get those hypotheses in. So we're using a 5% significance level to find the critical region that the probability of getting the number 1 is less than 1/5. Actually, let me describe what the X random variable is. It's the number of trials needed to get the first instance of the number 1. Alright? So, let's see why this is useful when comparing to the hypotheses. So the null hypothesis is that the probability is 1/5, and the alternate hypothesis is that the probability is less than 1/5. If I want to show the probability is less than 1/5, I would need for there to be lots of trials before I saw the first success, for it to be low probability. So I'm looking for this region off towards the right tail. Be really careful on this. A lot of people assume that the null hypothesis has a less than symbol, so that the test statistic will also involve less than symbols. If you remember in year 12, I kept on going on about compare to the expectation so you don't fall into this trap. Okay, so we're looking to find a value where the probability that it's greater than that value and the probability that it's greater than a consecutive value are going to be above and below the 5%. They're going to hone in on the 5%. And with some calculator work, I can see that 14 greater than or equal to 14 is 0.0550, and that greater than or equal to 15 is 0.0440. So I can see from there that the one that generates a probability less than 5%, or the region that generates a probability less than 5%, is X is greater than or equal to 15. That is our critical region. X is greater than or equal to 15. Okay, always set up these two values, demonstrate them by showing them on the paper, but it is down to some calculator work for you to find the two consecutive values where one is above the significance level and one is below the significance level. Alright, part B actually asks us to write down the actual significance level. So the actual significance level is basically the probability of the critical region. So the probability that X is greater than or equal to 15, and we've more or less done this already. We know it's that 0.0440. So the actual significance level is 4.4%. Okay, we'll do one last critical region hypothesis test here. This time round, we're testing the contactless payment system known as Lobster Card, very popular in the city of London. Okay, so apparently the company or the administrator says that only 1 in 1,000 will be rejected, are going to have issues when it comes to the gate. But a station manager feels that the company is understating that proportion, so understating once again. And we're going to go ahead and carry out a hypothesis test. When the station manager comes on shift at 5 o'clock, he pays attention and he's going to wait until the first person has an issue, has a problem with their Lobster Card. So once again, this is a geometric distribution. The probability, we're told earlier in the question, is 1 out of 1,000. So the expectation is 1,000. We would expect for 1,000 customers to be able to use the system before we came across the first one who had a problem with their Lobster Card. Okay, here's the diagram. We think they're overstating, alright? So, we're looking for the probability, or the null hypothesis is 1 over 1,000, whereas the alternate hypothesis is the probability being greater than 1 over 1,000. For that probability to be greater than 1 over 1,000, we're going to expect a lot fewer customers to need to come through before we saw one that was faulty. So we're setting up both of these probability statements with less than or equals to inside them. We're once again looking for one of these statements to be below the significance level and one to be above. So some trial and improvement on my calculator, I've managed to hone in on 51 and 52, with the probability that x is less than or equal to 51 being equal to 0.0497. Well, basically it was the one that was smaller than the significance level. So this is how it would be depicted on the diagram, and my critical region is just the inequality x is less than or equal to 51. Any result that I got from this experiment where less than or equal to 51 customers came through before we encountered the first 40 lobster cod, we would have evidence to reject the null hypothesis. Okay, once again, the actual significance level in this case is the probability of the critical region, and that's the probability x is less than or equal to 51. If you use the technique I'm showing you, you would already have that answer written down, 0.0497, which is 4.97% for the actual significance level. So just be careful, in this question we weren't even asked to draw any conclusions, we were just asked to actually find the critical region and to state what the actual significance level was. You'll lose no marks for coming up with a conclusion, and it's actually practice if you do, but just be mindful of exactly what the question's asking you. In an exam situation, you're up against the clock, you want to make sure that you've answered the question fully and efficiently, and you're not spending time on unnecessary aspects.